All right, now it's my pleasure to introduce our final speaker, Blair Newman. He has strong technical expertise and over 20 years of leadership experience. He's engaged in overseeing Newton's business solutions and ensuring high-quality services are delivered to clients. As Newton's CTO, he provides unprecedented insights into the future of AI's development and use. Let's welcome Blair to the stage for a discussion on AI at the sensor level.
All right, thank you. I appreciate that. And I'd like to extend my thanks to all of you guys. I'm a bit of a wanderer, so if I walk off the stage, it's not that I've given up or anything like that. But thanks for having me. It's a pleasure to be here. And prior to coming here, because I'm a bit of a nervous flyer, I was speaking to one of my sons, and he was inquiring about where was I going. I live in California. I said, well, I'm going to Phoenix. And he said, oh, that's not too bad. I said, well, you know, it's actually a pretty dangerous trip. And he was wondering why it was a dangerous trip. Okay, all right. Okay, all right. And he was wondering why it was a dangerous trip. I said, well, I'm the last speaker of the day. And I'm in between everyone in the audience and some beer, some wine. And I said, that's the last place you want to be at the end of the day. So I appreciate you guys for being here. And I got a couple of things that I would like to share with you guys today. Number one, my objective is really kind of twofold. One is I want to share how we bring all of the technology that you guys have discussed over the last day and a half to life, where you can really feel it and also touch it. In addition to that, since I have about 20 minutes, my other objective on this dangerous mission is to make all of you guys data scientists before this presentation is over. So my objective is to empower all of you guys that when I finish today, you can bring intelligence to any device that you might have. So that's my secondary objective today. Now, how do we do this? So we do this, really, there's a couple of different pillars in order for me not only to be successful in today's discussion, but to ensure that all of you guys are successful. One of the things that we do is that we marry, or we combine, technology as it relates to whether it's a low-power sensor or whether it's an MCU with a machine learning model or with intelligence. And the combination of the two is what really is critical for success. But there's another pillar in there that is not mentioned, and that's people. You gotta have a solution that actually empowers your customers to want to gravitate to. So for myself, our organization, we've been around for some time. We've been around for a little over 18 years. Myself, I've been with the company for 8 years. And we've been in the machine learning business, building models, bringing intelligence to our community for the last 5 years. Now, why do I mention that? I mention that because roughly at that time, we really began to hear about tiny ML, edge ML, because everything is cyclical. First, we wanted to bring everything to the cloud. Now we said, oh, we don't want to bring it to the cloud anymore. We want to have that information, that decision, that intelligence right at our fingertips, right? And so we started that process 5 years ago. And when that process began, they said, oh man, we want to have billions of devices on the edge have intelligence. Now, how do you accomplish that? Especially since data scientists are rare, et cetera. So we embarked on this mission to make AI available to everyone. And we took that in a very, very literal sense. How can I ensure, how can I empower everyone to bring intelligence to their device irrespective of their silicon that they're using? And that's what I'm going to share with you guys today. So you got to have a solution that's important to people. So what we're going to share with you guys is how we brought those solutions to life. And I began to think about it. What are some solutions that would be important to me? I like to sit around, watch football. And I'm like, man, do I want to grab the remote? It's 6 feet away. How can I change the channel without actually touching the remote? Is that possible? I don't know about you, but I have a couple of kids, and they tell me they brush their teeth every day. But in reality, they don't. So how can I check and validate that they're actually brushing their teeth? You know, your kid comes out of the room, you say, did you comb your hair? Yeah, I did, but it's a mess. Well, not me, but, you know, they say, hey, it's a mess. How can you validate that they're performing all of the activities that they're supposed to perform every single day? I don't know about you, but I get a lot of Amazon packages, and oftentimes they're destroyed. So how can I identify from a logistics perspective when my package was damaged, how it was damaged, etc.? So we're going to share with you guys a number of different solutions that we've been able to partner with some of you guys in the room to bring to life. Now, in order to accomplish this, we had to do a couple of different things. If you want to bring intelligence to millions, number one, you got to throw what you're doing today out the window, which is what we did. Bringing intelligence to everyone, we said, no, we're not going to use all of the algorithms that are out there. We decided to create our own, patent our particular approach, so that now when you build a model so that you can embed that intelligence into your device, guess what? You're going to be able to do it in one iteration. It's going to be able to be embedded into any device, irrespective as to who you choose to use. You don't have to have any technical skills in order to accomplish that. You don't have to worry about, guess what? How much memory do I have? Because we're producing the smallest models on the market. And you're able to embed it immediately, natively, right outside of the box. And so our objective is not only to bring the technology, but also to bring the usability, where we've actually democratized it so that anyone can accomplish some of the things that we're discussing today. Now, why would you want to do this? Obviously, when you talk about sustainability, you want to be able to embed your model so that it doesn't consume up your battery, etc. You want to use your MCU as an example for business logic and intelligence. So we embed our models directly into the sensor, only waking up that MCU when it reaches specific requirements. I always like to say, especially when you're talking about edge ML, tiny ML, bringing intelligence to the edge, and you want to be able to, let's say, measure things on an ongoing basis without worrying about your battery being consumed. That's some of the benefits of having a model that's extremely small, extremely compact, and can produce the results that you're looking for very, very quickly. So when we began to talk about AI in action, I shared with you guys some examples of how you're able to maybe control various devices within your home without touching a button, etc. And we'll show some of those examples in real life. You walk out the room and your wife says, oh, did you turn off the TV? Now you got to walk back. Well, we can eliminate that. You can, wherever you're at, you turn off the TV. You don't need to touch anything. So here's an example, not yet, where we have a buttonless solution, where we had the opportunity to partner with ST Micro and be able to put together a solution that identifies just your gestures. So you just swipe right if you want to change the channel, or you might swipe left if you want to perform some other particular activity. And by the way, these are just examples of intelligence that we're able to embed into the sensor. If you have other gestures, other functions that you would like to implement, you can certainly do that. We work with one of our partners where now all of their salesmen are out there performing all of their presentations without holding a clicker, because their motions, their gestures are able to be recognized by embedding intelligence directly into their devices. And I would like to direct your attention to how small these particular models are, meaning that It's an extremely small footprint. And all of these solutions that we're talking about today, they're embedded directly into a respective sensor. And again, here, when you talk about hands-free interaction, here's a very great story I like to share. Apple, they just released this. You might have seen this a couple of weeks ago. We've had it for months. They said, oh man, you know, we can now, you can recognize all of the gestures with your Apple smartwatch. It took them some time to release this. Why did it take them some time to do this? Because they, in the end, they had to dedicate an MCU just to be able to identify the gestures. We said, you know what? Let's eliminate, let's bypass the MCU, and we have this solution by working with Bosch, and we've embedded the model directly into the sensor without even needing to even access the MCU in order to bring this intelligence to life. Now, we have a quick little video here where we'll share with you guys some of these solutions in action.
Small neural networks allows you to analyze dozens of gestures and types of touches for numerous devices. For example, enhanced gesture-based solutions allow you to control any smart home device, such as your television, thermostat, home lighting, or your entertainment system. Just imagine the possibilities of controlling any of these devices with just a smart ring.
Here is an example of a gesture interpretation model embedded directly into a programmable sensor. Such a model can control a TV, radio, or any other device that requires a remote. Tapping your finger starts and stops playback. Swiping left and right rewinds. Clockwise finger rotation increases volume, and counterclockwise makes it quieter. Assistive touch. A tiny Newton machine learning model is trained to recognize subtle finger movements to control a smartwatch. 5 gestures: activate device, pinch, double pinch, clench, and double clench. Let me show you. I'm using an Arduino Nikola Sense ME, which hosts a variety of different sensors, but for this demo we're going to be using only the accelerometer and gyroscope. Here we have a smartwatch interface, and pinch is programmed to navigate the menu forward. Alright, let's do this again. Okay, so we've moved through 2 menu options. Now if you want to enter the menu, clench, and here we go. Double clench to exit, and double pinch to navigate the menu backward. This model consumes only 3.2 kilobytes of flash, 1.4 kilobyte of RAM, and predicts in under 1.5 milliseconds on this device.
Leveraging ultra-small neural networks allows you to analyze dozens of gestures and types of touches for numerous devices. For example, enhanced gesture-based solutions allow you to control any...
All right. I guess he liked the video. He wanted to see it twice. But part of the beauty of this solution is that you're able to develop this solution. You can bring it to your customers, bring it to your partners, and there's no coding required at all. And you're able to do this in one iteration, irrespective as to the device that they're specifically using. Now, I mentioned earlier, in addition to that, we talked about being able to identify various different human activities that may exist, whether you're combing your hair, whether you're brushing your teeth, whether you're washing your hands, etc. These are all tasks that bringing intelligence to a sensor enables for you to bring that life to your device that certainly your customers can get a tremendous amount of value out of. Now, here we talked about, or here we'll show in just a second, a number of different human activities as it relates to the solution. And kind of going back, whether it's for elderly care or whether you're looking to identify and track some of the activities that maybe some of your kids or other individuals are doing. That's certainly some value there. And then also when we talked about when it comes to personal hygiene, not only do we have the ability to identify if you are actually brushing your teeth, but how effective are you brushing your teeth, right? So I'm sure some of you guys probably have a smart toothbrush that is out there, and most smart toothbrushes, whether it's Oral-B or from Procter & Gamble, etc., you typically might have to bring your phone with you. So you're brushing your teeth, and the idea behind these smart toothbrushes that they have out there is that it'll let you know if whether or not you did a good job. In this particular case, I don't know about you, but typically when I get up in the morning, I'm not bringing my phone to the bathroom while I'm brushing my teeth. One of the things that we do, and in addition to that, of course, in order for them to give you those results, all of your data, all of your information needs to go through the cloud or to your device. Now we're eliminating all of that completely, where we're providing all of that level of intelligence directly on your device. And while you're brushing your teeth, it will notify you if whether or not you've actually addressed all of the various quadrants. If you're using other things like a water flosser, etc., then certainly that can be used as well. And here's again a solution that we've actually had the opportunity to implement, where once again, bringing that intelligence directly to everyone's fingertips. That has been our objective. And our customers, our partners have been able to take advantage of this solution. And then lastly, when we talk about logistics, being able to track a package now directly into the sensor. In a lot of cases, with the size of the sensors that are out there, they're embedded directly into the label. And you're able to not only track the quality of the package as well as while it's en route, but you're able to really perform a number of different complex activities, tracking the location, tracking the quality of the package, did it fall, is it in this right orientation, etc. And then you're able to pinpoint if whether or not or when a particular event actually occurred. Now you're bringing intelligence throughout the entire supply chain. Now here we'll have a video where we show and demonstrate all of those particular solutions in action.
For various solutions. Daily human activity machine learning models allows for multiple solutions to be realized, such as caring for the elderly or individuals with disabilities, and even the supervision of children. For instance, now you can know exactly how many times your child may have washed their hands at school, or if a person of care has completed the necessary personal hygiene needs for the day.
This model inside an ISPU sensor can recognize 5 different human daily activities. Let me show you. The first one is brushing hair. And right now on the screen you can see the predicted output. Brushing hair. Okay, very good. The next one is washing face. Hopefully the output right now should be washing face. Okay, very good. Now washing hands. Okay, the next one is gonna be brushing teeth. So here I have a toothbrush. Okay, very good. And the last one is wiping a table with a tablecloth. Okay, perfect.
As you can see, we can not only understand when someone is brushing their teeth, but we can also determine which area of the mouth they are brushing at any given time. Our tracking solution toothbrushes allows us to track 15 areas of oral cavity and display it directly on your device without using a mobile application. Now let's take a look at a logistics solution where we provide the ability to track any package in transit to determine the quality of handling in real time.
On-device package tracking model can help monitor the valuable cargo delivery state. Our ISPU sensor is placed on top of the package. First class is idle. The package is laying on the table, nobody's touching it, and the model outputs right now idle. Next up is shaking. So I picked it up and I'm shaking the package and the model outputs exactly what's happening. Shaking. Now let's test for impact. Impact. Very good. Now there can be different types of impact. I can hit the package or like this, and we have 3 events of impact. What about a more serious impact? Free fall. Now this test is going to be twofold. Hopefully it's going to predict two different classes: free fall for a split second when the package is flying, and impact when it hits the ground. Here we go. Okay, free fall, impact, impact. What about orientation tracking? Suppose the package has to be this side up, like this sticker here says, and if you flip it over, okay, wrong orientation. And like this, again, wrong orientation. The last two states are connected with active movement, transported by courier and transported by car. Let's do the courier first. So here I have the package and I'm walking with it. And the model outputs right now, transported by courier. For the last event demonstration, I'm going to head over to my car and I'll see you in a minute. As we can see, the model accurately determines that the package is transported by car.
Newton enables any device to recognize dozens of human activities.
So here you can see a number of different solutions that by leveraging artificial intelligence, by bringing intelligence to your sensors, it really brings life and value to your customers. And that's really our objective. Our objective, as I mentioned before, is to be able to accomplish this not only from a technical perspective, but also help our customers realize the value of marrying that technology so that they can now take that next step as to how they can continue to drive value for their customers. And there's a number of other solutions that we work with, or areas that we work in. These were just a few that we thought would certainly resonate with you guys, some activities that are day-to-day activities, but more importantly, these are also areas where we have found that there's a tremendous amount of traction when you begin to talk about growth in this particular space. Now, one of the things that I shared with you guys is that I would enable all of you guys to be able to produce these models. Now, by leveraging our platform, we've really streamlined the ability to be able to produce all of these solutions that you've just seen today. Our workflow is really clearly just 3 simple steps. There's no coding that needs to take place whatsoever. So by embedding the model, let's say directly onto your sensor, we're able to take that data as it comes and is read through, let's say your IMU as an example. So by doing so, you only simply need to upload your data. You click Start Training. Once you click Start Training, we'll then facilitate actually building your respective model. Then after that, you can download your model, and natively out of the box, you can then embed your model directly into your respective device, no matter which device that you may be using in that particular time. And so with that said, I'd like to say thank you. And it's been a pleasure to be here, and I think that does it for me.
Let's take your questions for Blair? Maybe you want to start with, for someone that's not familiar with this, how long does it take to implement this technology?
So that's a good question. So I like to break it up into 2 different phases. One phase is we have some customers who have never at all experienced machine learning at all. They just have an idea that, let's say, they want to bring more efficiency to a washing machine, as an example. In that particular case, we'll come in, we'll work with the customer to identify which data that they need to gather, and then assist them in training the model. That proof of concept will typically take about 30 to 60 days in order to help them realize a proof of concept where they can validate if whether or not they want to move forward. Now, the process of actually creating a model and producing a model is typically hours, because we automate everything from a technology perspective. So the lion's share of the effort is actually collecting the data. Once the data is collected, then being able to produce a model and then embed that model is relatively quickly. But the entire life cycle would go anywhere from 60 to 180 days from being able to go from proof of concept, and then you have a production grade model that you would feel comfortable embedded into your devices.
I'm now going to get the glares because I'm stopping everybody getting a beer, but that's okay. Everybody in the room are, well, hopefully many people in the room are MEMS device manufacturers, and obviously you're enabling some of their technology, but what would be your call to action for many of the device manufacturers in the room?
Yeah. So where we have seen that there's typically a lot of value is when, and we do this quite often, so we will work with some of our partners, let's say as an example, Bosch. We will work with them and then we'll put together a solution with their respective device so that then their customers can actually see it in action. Because oftentimes when you are having an opportunity to speak with someone and you say artificial intelligence or you say machine learning, it oftentimes doesn't resonate with them at all because that's typically not their space. But then if you actually have a demo or you have a solution that you can show them and they can touch and they can feel it, then oftentimes that really, really resonates with them. And we typically do that with all of our partners is we'll identify a solution that aligns with their particular market space, whether it's on the industrial side, whether it's on the consumer side. We'll help put together a solution so that their customers can really get a good feel for how everything works.
Maybe one more question for me. Where do I get those smart toothbrushes? 'Cause